This is an introductory video on an open source large language model pipeline project called MediNote-AI. The objective of this project is to create medical notes tailored for specific disease profiles to closely mimic physician notes. So the idea is that the user actually enter its information, its health information in an app, or via a conversational AI that actually the user even can talk to that conversational AI and tell about its health and so on. And the model converts that into more like a structured format, which is mimic like a physician notes. And not only that, the model detects these gaps in this form and try to interact with the user to fill up the gap and complete this information as much as possible. But not only that, this application has a potential to become more like a health management system, either a personalized health management system for everybody, or it turns into a clinical health management system. For example, the application can detect that to complete this information, the patient needs to, for example, take urine test or blood test, or even, for example, some genetic testing, which some of the physicians are not even familiar with many of these genetic testing. So in a way, it helps physician. And also, for example, even propose some prescription and so on. And not only that, when the result of this prescription comes, it can even generate reports of this prescription, something like a LabCorp reports. So in a way, the target of this application is actually, at least the original target, is not the end user, is not patient, is physicians. These notes is going to help physician to do a better service. And for example, to create a more comprehensive notes and results. However, such an application requires a more or less complex architecture. You cannot develop this application with just single large language model. The reason is because all of these large language models intrinsically, they hallucinate. They are probabilistic models. On the other hand, they are creative, and that's a good part of it. And we can leverage the creativity part of these large language models. And also, they're easy to communicate because they understand, conversational, basically natural languages. So we want to leverage all these features, but we want to also, prevent these hallucination as much as possible. And that's the reason that you more or less need to rely on medical applications such as databases or legacy systems which are already present in clinics and hospitals to actually prevent those hallucinations. These are the factual systems. They are based on facts. They are deterministic. So for example, if you basically submit the same input twice, you get the same result back. This is not the case for large language models. Also, they are verifiable. Many of them are interpretable. You can interpret the result. On the other hand, they are hard to communicate. They require API connectivity, special training, getting certificates, and so on and so forth. So in a way, this system should be able to connect these two, basically these large language models and also medical applications. And these connections is via something we call agent. That agent more or less represent that physician, represent the clinic, or even represent the patient. And this representation, meaning that this agent is customized for that specific host, that let's say for a specific patient, and that is done via something called embedding space. So in a way, we need also to fine-tune some encoder models to generate this embedding per patient. So as you can see, there is not even a single model involved in this architecture. There is a model that generates this embedding space. There are multiple models here because it's not only large language model. You probably need like a vision transformer model to be able to interpret and to be able to mine, for example, X-rays, MRI, and so on. And also, you may even need more than one large language model. So all of these should come together such that you can have a right architecture. Here, you can see 6 of these legacy applications. Of course, there are more than this, but I just want to go over these. And we can develop in these open source the connectivity from agent to these systems. So for example, these systems can be electronic health records, which actually keep track of the patient information in a database and so on. For example, PACS, which is usually used for X-ray, for MRI and so on, manages those large files and so on. A laboratory information system, LIS, which keep track of the blood test or urine test or any other genetic test and so on. Billing system, which is again somehow related to more or less patient information. Pharmacy, and finally scheduling, which is also another important aspect that AI can help in terms of how you schedule patients and basically manage priority and so on. We also developed this application such that you can plug any large language model to this application. So for example, it would be a model neutral. Let's say you can plug Llama to Mistral or any new model that may come up later on. It fine-tuned that model in a more or less automatic pipeline, and then it generates 2 separate fine-tuned models. One designed to run on a GPU, using some of these latest technologies such as LLM, and another actually fine-tuned for CPU. So you can actually run this application on maybe even your own laptop. And this is important because we want to be sure that all the contributors can actually play with the application and even work with that and give us feedback. And many of them may not actually have access to GPU. Finally, I want to talk about the incentive for contribution to this open source project. First of all, this open source project is based on Apache license, so you can always take this project and commercialize it. And I envision that there will be probably many spin-offs from this project that end up to be a startup, some successful, some may not. And to launch a startup, probably the most important factors for the success of a startup are these factors. First of all, having a cohesive and competent team, which through this contribution, you can actually find these team members. You can find out who you can trust and count on it, and your chemistry basically align with that person. You want to be sure that you can have some public reputation, which help you to do fundraising, to basically spread the word of your idea. And this open source project actually have this utility, which actually create a public reputation for you as a contributor. It minimizes the risk and transition barrier for customers, because the customers, without any basically they count on this open source project because they can always customize it. They are not tied to a specific basically vendor and so on and so forth. So it's easy to convince customers to use this open source model, and then if they wanted to customize it, then they can come and basically pay you for this customization. And also building a global network, because there are many contributors to this open source project from different parts of the world, and your network grow via basically connection to these contributors. So in a way, we believe that with the open source project, you can more or less start applying for grant, and also you can, basically offer these open source as a trial, and create a custom version on top of that. And these triangle actually help to spin off many startup projects. So typical basic revenue models for these, startup which is based on which has a core open source, core, are freemiums, which they have like a free version and a premium version. We are consultation to more or less customize and help to, for example, deploy this open source project. Again, we are training and certificate, for basically the intellectual property that is embedded in this open source project. And also, as we pointed out, you can always take these open source and commercialize it. And this commercial transition is much easier when you have a strong open source project. Finally, I want to mention that the name of this project is actually proposed by ChatGPT. I asked ChatGPT to propose a name for such a project, and even this logo that you see is generated by DALL-E. I asked ChatGPT that I have this project, generate a logo for me, and it generated this one for me. So yeah, I'm hoping that with your contribution, we can launch a project that all of us will be proud of.